Hello everyone, I am Afsha Mulla from Sri Siddheshwar Women's College of Engineering, and in this video we are going to learn ion exchange process for removal of hardness of water. Now first of all, let's see the introduction. Hardness of water is caused by calcium and magnesium salts. Now whatever calciums and magnesium salts are present in water makes it hard. Hard water creates problem in domestic and industrial use, and it is not considered suitable for either domestic purposes or industrial purposes, and hence ion exchange process is an effective method to remove hardness from the water. Now what is hardness of water? There are two types of hardness: temporary hardness and permanent hardness. Temporary hardness is basically caused due to bicarbonates of calcium and magnesium, and this hardness can be usually or generally removed through easier method. But permanent hardness, which is another type of hardness which is caused due to sulfates and chlorides of calcium and magnesium, is difficult to remove. And both types of hardness, that is temporary and permanent, can be removed by ion exchange process. Now principle of ion exchange process is that it is based on exchange of ions between water and resin. So here the main work in this ion exchange process is of resin we use. The ions get exchanged between water and resin, and we remove hardness from water. Undesirable ions are replaced by harmless ions. In this process, we use cation resin and anion exchange resin. Ion exchange resins. So the both types of resins which we are going to use in this process: cation exchange resin, it removes cations like calcium and magnesium ions, and anion exchange resin removes ions like chloride and sulfate ions. Resins are insoluble and organic polymers, so hence it does not mix with water and cause any problem. Now this is the process diagram, where here we can see the raw water entering the tank or the cylinder, and here cation exchanger is present. This cation exchanger removes the ions like calcium and magnesium and replace it with the H plus ions, which is further, the water further moves to the anion exchanger, where anion exchange resin removes the ions like calcium and replace it with OH minus, where H2O is formed, and through this whole process we get deionized and mineralized water. So the working of ion exchange process, as I said earlier, hard water is passed through cation exchange resin. Ca2 plus and Mg2 plus ions are replaced by H plus ions. Water then passes through anion exchange resin, and anions replaced by OH ions, forming pure water. The chemical reaction which takes place is 2RH, which is our resin, basically, which reacts with the calcium ions present in our hard water, and the anions exchange, and this resin takes the calcium and gives out the H plus ions to the water. Similarly, Mg2 plus ions are replaced with H plus ions, and in anion exchanger, our ROH, which is an anion resin, replaces chloride ions with OH minus ions, and which forms H2O. Now one very big advantage in this process is that the resins used can be regenerated. It means that they can be brought into the same form as they were initially, to reuse them to remove hardness from the water. The cation resin are regenerated using dilute HCl or H2SO4. So whatever undesirable or waste resin you can say is left out after the process of ion ion exchange process and after hardness is removed, that resin can be regenerated using HCl, and which can be again used to again remove the hardness of water. Similarly, anion resin is regenerated using dilute alkali NaOH, which in this process restores the efficiency of resins, and they can be used as they were earlier to remove the hardness of water. Advantages of this process is that it removes both temporary and permanent hardness. It produces very soft and demineralized water, which is very good to use, compact plant size and high efficiency. This process gives out, like, removes complete hardness from the water and is very efficient. Now, disadvantages of this process is that it high initial and maintenance cost. So whatever process we saw is easy to think, easy to say, but to do it and apply it actually requires a lots of maintenance cost, and very initial investment is very high in such process. It requires skilled operations and it is not suitable for highly turbid water. Applications of this process can be in boiler feed water treatment, laboratories and pharmaceutical industry, chemical and power plant, domestic water softeners. Now, in conclusion, we can say that ion exchange is an effective water softening method widely used in industries requiring high purity water. It is essential process in modern water treatment system. So thank you everyone. I hope this ion exchange process was clear to you. Thank you for staying till the end. Bye bye.